And we are live. So this is a video that normally I would not be sharing publicly. But every single Thursday at 6 o'clock p.m. I go live, and it's almost 6 o'clock p.m. in my time zone, which so happens to be Mountain Standard Time Zone. And this is for the DevSecOps Dojo, but what I am doing differently today is I'm going to share a little bit about, like, what do we do in the DevSecOps Dojo? So this is the first recording of a session that basically the recording didn't work out, but I had delivered the session live. And I don't really share what we do in the dojo, not really, not often. And I don't really talk about what we do in the dojo. And so since the DevSecOps Dojo is pretty much where I spend pretty much like all my time over the past like 2 months especially, I haven't done anything else but work in the DevSecOps Dojo, which I love, by the way. So first and foremost, what is the DevSecOps Dojo? The DevSecOps Dojo is where I teach DevSecOps, which is a philosophy that's similar to DevOps, but incorporates the concept of having security in your DevOps. And DevOps is a philosophy around development for continuous operations and continuous integration, that sort of thing, things of that nature. So if you have ever heard of the concept of disaster recovery, what this session that I'm going to share today is all about disaster recovery. So in the DevSecOps Dojo, what we do is we talk about cloud technologies, and I teach not only how to build cloud technologies from ground zero, like from ground up, from your own apartment, from your own garage, from your own home, from wherever you are. I don't know where you live. All I know is that the DevSecOps Dojo is for wherever your home is. And it's designed to teach you how to build cloud, and then go all the way from, learning the very basic fundamentals, which is where we're kind of moving on from. So in November, I spent time teaching a lot more fundamentals in the DevSecOps Dojo. Now we're moving on toward, okay, so we know fundamentals. So this training right here that I'm going to share publicly is a little more advanced than what beginners might consider. It's not the most beginner-friendly lesson. This is for people who are a little more senior. If you're probably making somewhere north of $70,000 a year, this might be relevant to you if you're working at a company, or if you're just like an extreme hobbyist, which you people exist. I'm technically one of them. So there are a number of us who are hobbyists who like to build things at home. So I build cloud technology for fun at home, all those good things. Anyways, so disaster recovery. Today I want to talk about what is disaster recovery, why does it matter, and when we're talking about DevOps, DevSecOps, then what does disaster recovery have to play in DevSecOps? Because it's maybe one of the most important things when we're talking about building continuous technologies. Because inevitably, let's say, so what's a continuous technology? If you're going to Facebook.com or YouTube.com or LinkedIn.com, and right now I'm streaming to Vimeo, YouTube, and LinkedIn, all of those websites are continuous technologies, which you could otherwise consider continuous platforms or continuous delivery platforms. And so DevSecOps has to do with these things. So if you want to have a job at a company like Facebook or Google and some of these things, and you want to have one of those jobs where you work on the back end to make sure that Facebook never goes down, make sure LinkedIn never goes down, make sure these things never go down, that's when disaster recovery comes into play, because inevitably something's going to go down. I believe last year we had an outage in AWS, which is Amazon's cloud, Microsoft's cloud, which is called Azure, and Google Cloud. All of them had outages. And someone has to have the job of making sure that those outages get addressed, get managed, get maintained, all those good things. And then if you ever dare to start your own company and you ever dare to start your own hosting, have mercy, because everything is going to go down at some point, and you should have what's called a disaster recovery plan in place, and we want to talk about what that is. So I'm going to provide once again, so normally folks are going to have to pay $150 a month to join the DevSecOps Dojo, because it's a co-op where we actually help you develop technologies, cloud technologies, learn. So it's a great place to learn cloud. It's a little more advanced than the beginner fare. So anyways, without further ado, let's talk about disaster recovery. And so for those of you who so happen to be from the dojo who didn't make it to the session, a number of you did make it to the session, then you don't need to watch this. But for those who missed this DevSecOps Dojo session, let's get into it. So what is disaster recovery? Let's just think about this, because I teach in first principle thinking. What's first principle thinking? First principle thinking is, let's break things down into their most basic elements to make things that are otherwise super complicated not nearly as complicated as they already are. Cloud, when we're talking about having thousands or millions of servers working together like one system, like Facebook or LinkedIn, they have servers. They have millions of servers running these platforms. Netflix, doesn't matter. Well, the longer you run something, the longer you run an application, the longer you run a computer, the longer you run your laptop that you work. Let's say that you just have a laptop at home and you run it for see how many days you can keep it online and keep it running. Inevitably, whether there's a power outage, internet outage, or your system has a system failure of some sort, your laptop's going to go offline in terms of like off the internet. So there are ways to make sure that when the time comes, because we want to understand that disaster is going to happen, not if disaster happens or disaster might have. It's not even a matter of like insurance of like if it's going to happen. Disaster is going to strike. You're going to get hacked. You're going to lose data. You're going to have system failures. You're going to have internet outages. I don't really care what disaster happens. It's going to happen. I've dealt with companies that have been flooded and no longer exist. Companies who have recovered from trying to survive after fires and everything being burned down. You name it. Like, I've worked with these types of scenarios before. So something that makes no sense, that you never expected, you never planned for, you never imagined was going to be something that you should really care about. I have no idea what that disaster is going to be, but disaster is going to strike. It's going to happen. It's just how it works. So the longer you do something, anything, driving, if you drive more than most people, you're going to end up running into a lot more issues on the highway than people who don't drive very often. Simple things. Like, so that a lot of that is just probability. Now, the concept of high availability, we're going to talk about that. We're going to talk about the fact that something goes wrong the longer you do things, and then we're going to talk about the concept of what's called high availability, which is if something goes wrong, how do you make sure that you have something highly available for when disaster strikes so that something that bad doesn't have to happen. And this is kind of interesting because the very reason why I am re-recording this right now is because I had a dojo session. I was teaching disaster recovery for that dojo session, and things went wrong from a technical standpoint. There was a Windows update. That Windows update did weird things to my system, and then configurations that allowed me to record my streams that normally work and stream to teach my lesson didn't work. But I always keep 2 systems on my desk, and I have a grand total of 4 systems total that are designed for making sure that I can still teach my lessons or do my demos or deliver my services, whatever I'm doing as a business owner. Because as a business owner, I've had everything go wrong at some point. You name it, it's gone wrong. So I ended up having to deliver this training on a completely different system. So this is the concept of what is high availability. We're going to talk about that. Having something that's highly available for when disaster strikes, in case you really do need to make sure that you can still continue doing business. Now, development life cycles should all have a DR plan. That's something we're going to talk about. Now, if you want to know what development life cycles are or how development life cycles work, that's something that I'm going to say, please join the DevSecOps Dojo to learn, because that's so complicated that there's no way I'm going to spend much time on people in the public domain trying to learn this stuff, when really I probably need to be having conversations with you and directly interacting with you in order to really kind of walk you through like development life cycles for those of you who've never done these things. There's a reason why people go to college and things like that. You could think of what I do as an alternative to college, I guess, or something that you might do on top of going to college, because college doesn't necessarily provide some of the real world experiences that I provide, but I also don't provide some of the background context that college provides. So anyways, some things to think about, random concepts, because people have asked me, what do you do in the dojo? Because I spend pretty much all my day in the dojo building things. So let's kind of take a look at, like, what do I do in the dojo? I build code. I build code like 24/7. And I wanted to move what I was doing from being in a situation where I was trying to sell so that I could build our enrollment and do code at the same time, which that doesn't really mix. I'm not really a salesperson. I could care less about sales. I could care less about numbers of sales. I could care less about metrics of numbers about sales. I'm not a salesperson. I'm a coder. What I care about is building risk models and building security operations center dashboards and things like that, and not having to worry about monetizing or funding these things. So I actually went out of my way to figure out ways to fund the business in a way to where I can almost quite literally just develop 24/7. That's what I want to be able to do. So this is what I do in the DevSecOps Dojo is I build open source software. This is an open source software platform called the Olympiad that I've been working on for quite some time that's on for release. There will be more information on that soon. If you're not in the DevSecOps Dojo, you don't know much about that. If you are, you know more about that than what I'm going to explain here, because really this is a catch-up training video for DevSecOps Dojo. So if you want to know more context about what this is, more context about what a development lifecycle is, spend time with me in the code dungeon, things like that, learn things in my code dungeon with me, all those things. That's what the DevSecOps Dojo is for. So let's get in to disaster recovery, because it's something very important. So if disaster is almost guaranteed to strike, and that disaster is almost like inevitable, like something's going to go wrong. Let's be blunt. If you work in technology and you're working with something for longer than like 3 months, especially, if you're just building a new little technology project and you're building a thing for a class, and that class is a 6-month-long class or a 3-month-long project and it's real temporary, who cares? But if you're going to have something that's going to go on for years, and if you're building a cloud platform or an application that you plan on monetizing or something along those lines, ultimately, you are going to run into a situation where it doesn't matter if you get hacked or if you have system failures. Reaction is king, and just, of course, we want to make sure we have our firewalls up so that we don't have to react to as many things as, like, more than we need to. Make sure you have antivirus, make sure you have network scanners, vulnerability scanners, all the things to scan as well. And preventative measures, intrusion detection, prevention, and intrusion prevention systems, all that good stuff. You want to have those things, yes. But once you have all those things in place, they just kind of run on their own. And so ideally, you want to have an idea of, like, disaster is going to strike, so we need to set things up to be capable of reacting. And that's what disaster recovery is all about, is planning ahead so that you have systems in place to be able to better react, which is what brings us back to things like this dashboard right here, where I've been building security operations center dashboards lately with SIM technology that I created because I felt like creating SIM technology. If anyone doesn't know where I come from working with SIM technologies. Logarithm was probably the one I'm most known for, but I've worked on more than just Logarithm SIM technologies. I've worked with Splunk technologies. I've built my own SIM technologies. This is the second SIM technology that I myself have built. But really, the purpose of building security operations centers, if you've ever heard of what a security operations center is, you can Google what a security operations center is if you don't know what that is, or join the DevSecOps Dojo if you want to know what these things are. But really, when we're trying to get into what in the world do we have these dashboards for, the purpose of these dashboards is so that we don't have to waste our time as analysts. So if you're building a way to protect a company, you want to keep those applications from getting stolen or from getting breached, or you want to make sure that the users using those applications have access to those even if you have system crashes, things like that. You want to make sure that your system environment and ecosystem works. So a lot of disaster recovery comes down to something called root cause. And so you want to kind of have an idea of, like, how can you identify the root cause of what causes a disaster at some point. So this is something that I'll be talking about later, but this is something that you can use for what's called incident response. And if you have a disaster, you have to respond to the disaster, and that's part of your disaster recovery process, which is, how do you identify an incident? Well, right here I have this dashboard that shows when something goes wrong, everything turns red. So let's see if I can find a time frame when everything was going wrong during one of my tests. And if so, we'll be able to take a look at what it looks like if things go wrong. Maybe not. We'll see. I won't spend too much time trying to... One thing I'm not good at is updating this little dashboard to show demos. I'm not very good at demoing this dashboard. I'm terrible at it. Let's change dates. Maybe Saturday? When did I have another disaster? Bam! There we go. Okay. So what I've set up to create something that lets say Security Operations Center dashboard is if things go wrong, I use color coding. Green means that if we have a bunch of system errors, well, this bar on the left, this indicates like, am I having system failures? Is a hard drive about to fail? Is my system about to go down? Think about Facebook again. Facebook can't go down. If Facebook suddenly has systems crashing to the point to where Facebook goes offline, Facebook loses a ton of money and loses enrollment and people get angry. So we have to make sure that the error rate of a system that's being managed and protected so that, if we have to react to something, if something goes wrong, we can. And then also, if we want to make sure that people aren't hacking our environment, then we have a couple of other things that we can cross-correlate here. But if anyone's ever heard of SSH, people hack companies using SSH oftentimes. So that's something that's worth monitoring so I can tell if someone's trying to SSH into my ecosystem, into my critical environment. Maybe they're trying to access something that's not critical. I could care less. But I monitor everything that's critical. So if you're trying to access my systems via SSH, I will know. I will know in real time, live. I'll know you're trying to hack me. And then on top of that, I can tell when there's unusual traffic activity here where it says when it's in red. Purple means that something might be worth investigating. Red means, okay, so when we're trying to analyze technology environments for disasters, we don't want to have to react to everything on the planet. We only want to have to react to something that's like, let's drop everything and deal with this. This might be a potential disaster. And so really, determining whether or not something's a disaster, if you have a complete environment outage, of course you have a disaster. If you're getting hacked, that's a disaster, but it might be a little harder to identify if you actually have a real disaster occurring in your environment. And so I've created a little dashboard to kind of help you identify different types of disasters that might put a business at risk, especially for like home workers. If you're a person who works from home, whether you're like a home-based entrepreneur or you're a home-based business developer, or you're a company that has a whole bunch of home-based workers and you want to make sure that nothing's happening to them and you have like pure isolation between their home environment and your business environment, that's the kind of stuff that I teach and build. So you want to be able to have things that let you react and identify if you're having a disaster, because if you're getting hacked, it's different from having like a flood. A flood, everyone knows like, oh no, the server room is being flooded. Well, great. Well, that's the easiest thing. You don't need a Security Operations Center dashboard to tell you that. Or like, the office is on fire. Okay, great. You can tell the office is on fire, but you got to react. You got to react to what's going on, and having a plan in place before a disaster strikes. If you're going to be running a business for 5 years, I've been running the business that I've been running for going on 4 years now, about to be going on 5. And things are going to go wrong. I don't know what else to tell you. If you think that you're going to run a business and nothing ever goes wrong, or you're going to launch a new application that's going to make its way into the market, you're going to monetize, you're going to make money off of these things, and you think that nothing's going to go wrong, I'm just going to let you learn the hard way, and I will just watch and nod when it happens, and then you can come talk to me. But anyways, that's besides the point. We just want to make sure that everyone understands that you want to be ready to react before disaster strikes, because it's just going to happen. And that brings us to the concept of what's called a Phoenix server. Now, most of you might not have heard of a Phoenix server. Well, I have a really strange audience. My audience is really niche. So my audience, maybe most of you have heard of a Phoenix server. But maybe you haven't. I have no idea if you've heard of a Phoenix server or not. So let's talk about Phoenix servers for a little bit, because this is the most important part of the lesson that I did recently. So I'm not going to get into as much as I did when I did the full lesson. These lessons are usually 2 hours long. We're not going for 2 hours. I'm just going to talk about the most important things, and you can Google the rest. And for those who are wondering, what do we do in the DevSecOps Dojo? We do this stuff for 2 hours every Thursday. That's what we do. We talk about these things, and we help you build projects. So right now we're building what are called blueprints. Everyone's building their own cloud application blueprint if you're trying to learn how to build cloud applications. Do you want to work for a company that builds cloud applications? That's the type of thing I teach. Do you want to build your own cloud applications for, I have no idea what reasons, a project, a company that you're trying to build, a vision, who knows, whatever that reason may be. So a Phoenix server is a server where any one part of the server can be destroyed and the server just keeps running. So this kind of brings us into this idea of where we start to bring in like cloud architectures. If you've ever heard of Kubernetes, if you've ever heard of Docker, if you've ever heard of clustering, you've ever heard of like VMware clusters, just clustering in general. It's where we can take like multiple servers, multiple systems, multiple applications, multiple hard drives, maybe 50 servers and 50 hard drives, maybe 50 servers and 5,000 hard drives. I have no idea what the configuration is, but a Phoenix server is a configuration where any one server can just be, go offline, or, go down, or maybe you have a process that crashes, because like Facebook has crashes all the times. LinkedIn has crashes all the time. Microsoft applications have, all technology has crashes all the time. But what matters more is that a lot of those things and a lot of those failures and crashes, you can build a Phoenix server where if one teeny tiny little piece goes offline or crashes, you have this very hard to destroy structure where you can take down one server and Facebook is still running. You can take down 20 servers and LinkedIn is still running. You can take down 500 servers and they're probably still running. And then you can take down the processes on those. You can have like 1,000 hard drives that died and everything keeps running. There was a scenario with Google, if anyone's been following an outage where Google Cloud, I don't know if it was Google Cloud or some Google service, but anyways, I have Google services and my email wouldn't even work. I think this was in December, maybe November, doesn't matter. And others who do business, their emails wouldn't work, and all of a sudden there's this huge outage. And while those outages don't happen very often, they do still happen, which is why, okay, so Google services went down. Someone has to get paid to get these things back up. But notice not everything went down. You could still access your Google. Well, when Google services went down, I could still access gmail.com, for example. That's because gmail.com runs on a Phoenix server architectures, where maybe the email's not coming in, maybe sending emails is failing, but at least I can still access it. At least something's still working. Not everything's completely down, and there's a skill set behind that. And this is the concept of Phoenix server architectures, the things where something terrible happens, something goes down, but it doesn't all go down at least. And then someone once again had to go through the disaster recovery process to react to the situation. And in the case of Google recently, their hard drives, or I think it was like a storage scenario where storage started having issues, where there were failures associated with storage. But not only did they have a recovery plan in place, not only did they implement that recovery plan, not only did they get everything back online, not only is Gmail working today and working well, but someone has to do that. Someone has to get paid doing that. They probably get paid a lot of money doing that, or they work for a company delivering a service that does that. But really, this is the idea of like right here. This is showing 3 different servers running a single operating system is the concept here, right? You might have 1, 2, 3 servers. So 3 is like a magic number where, if you have 3 servers doing the same thing and one goes down, whatever is running on those services is still accessible. And so Google stays up because it has thousands or millions of nodes. But a Phoenix server is where something can be destroyed and taken down, and it doesn't take down the whole company. So this is kind of covering the most important bits, but one thing that really comes down to this is, why does this matter? It matters because of something that we care about called business continuity. And business continuity says that we need to make sure that our businesses are going to work and run in ways that are going to be sustainable. And so we have to have reaction plans so that our businesses can continue when things go wrong. And that's business continuity. You got to make sure that things are working. You got to make sure that things look good. You got to make sure that things feel good. Machines don't have feelings, but people do. And so business continuity matters. So that's something that I'm going to let people go down a Google rabbit hole on. But just to give you an idea of some of our architectures that we started building is if you're actually building, say, let me go back here. And let's say I've built a Phoenix server architecture right here where we have 3 servers, right? Let's say we have 3 servers where these servers are running one application, right? I want to make sure that if one of the servers goes down, this application keeps running. I can access it. I can do everything I want to do with whatever this is. It doesn't actually go down. And so what a Phoenix server architecture is you can set up, so this shows 3 different servers in a visual representation, but there's a server called Cerberus right here. This is part of an architecture called the Olympiad. This is a Gorgon Gaze node, and then this is called the Inner Athena. But these are 3 separate physical servers, right? And if one of these servers goes down, I don't know, nothing happens. Nothing bad happens. Everything keeps working. And then I have all of the processes running right here. And these processes will continue running if I just take down one of these systems, one of these nodes or whatever in the cloud. Things keep working. So that's the concept of a Phoenix server, is that if you have an application running on something and this goes down, like I don't know if people play games or whatever, but like if you've ever played Minecraft, maybe you've heard of people can be like, yeah, you can have a Minecraft server. Well, if you have a Minecraft server and it's just one system and that one system goes down, then there goes Minecraft for everyone. But if you have 3 systems that Minecraft runs on, then it just keeps running, even if one system goes down and everyone can keep enjoying it. Which is why I use things like social media platforms as examples of that. But clearly we can see what it looks like. Let's take a look at what it looks like in modern times again to show you what it looks like when there's not some sort of disaster in the environment. Notice that one of these bars doesn't even exist. If there are no system errors showing up in my environment, this dashboard doesn't even show that I have system errors showing up. But one of the big things about disaster recovery is you don't want to create needle in the haystack scenarios where you're dealing with like thousands of, like this is a log right here, like this is a log. You're dealing with millions of these, right? And so I use color coding to let me know if I need to dig into these like logs, because there's no way I'm going to just waste my day digging into logs. I'd rather just be like purple, I probably don't care. Purple, yeah, I probably don't care. But you saw the red or errors starting to occur where a new bar appears, then I might be like, oh, maybe I'll look at those errors. Or, oh, it's red? Oh, something bad's happening, so then I can react. But really, you want to have a reaction plan in place. So that's what this is all about, and I'm going to go ahead and close the stream now. So if anyone wants to know more about Phoenix servers, disaster recovery, and building robust cloud applications, environments, all that good stuff, then you can join the DevSecOps Dojo or ask me what it's all about. I'm not trying to grow it quickly because I'm so busy that I don't really have time to think. But I really love what I do, so I'd love to have the few of you who think this stuff's cool. Feel free to come join us. So thank you and have a good day, and I hope you enjoyed the stream. And I actually have to go over to a DevSecOps Dojo training session right now to talk about the new things, because this is 2 weeks old content.